Okay, so I'm Yukako Yamane from OIST, Neural Computation Unit. And today I'm gonna talk about OptiNiSt, hands-on tutorial for OptiNiSt. OptiNiSt is a framework for calcium imaging data analysis pipeline. The development of this framework has started in the end of the last Kakushino BrainMind 1 project. We keep the development under the current no Togo BrainMind 2 project. It has not been used much in practical situations yet, but we'd like to increase its practical use and gather feedbacks. That is very important for the developer side, and consider what kind of usability improvements and extensions are useful and necessary for future implementation. In this tutorial session, I will explain briefly about the background, intention of starting this project, and overview what its OptiNiSt is, and then demonstrate analysis pipeline creation by this tool. So I said Q&A in the last part, third part, but please feel free to raise your hands. By the way, we cannot raise hands, right? Just
so raising the hand reactions. So
reaction. Okay.
yeah, this is
I'm not sure I can see it, but
okay.
please.
So if there's a raising hand, so I was checking.
Yeah. Okay. And or even just speak out to interrupt is fine for me. Okay. Then let's start. The calcium imaging data analysis takes multiple steps. It typically begins with pre-processing, such as motion correction, cell extraction, and deconvolution, if necessary. After extracting the activity of multiple neurons, we conduct a variety of analyses. These downstream analyses, like dimension reduction or clustering and so on, these analyses are also diverse and often need multiple steps. The method for analyzing large-scale recordings are still under development, and numerous methods are proposed and are available online. The table on the right here is displayed various methods for early phase analysis of calcium imaging. These methods are published continuously every year. Thus, the data analysis is often includes try and error, taking a new method, and comparison of multiple methods and their parameters. Thus, the pipeline becomes very complex. In such situation, keeping the reproducibility is very difficult. In addition, because many of these analysis algorithms are developed individually, when we wish to apply this to our own dataset, we need to prepare an environment to run individual tools. Again, this complicates the pipeline and introduce additional risk of reproducibility. OptiNiSt is a framework that helps address these challenges. That is allowing for the easy construction of data analysis pipelines compatible with multiple analysis tools. OptiNiSt supports creating analysis pipeline intuitively with GUI and showing results as a plot is very easily. and managing and producing pipelines easily and extensible by adding your own tool functions. And these functions, based on these functions, you can create a script for HPC use easily. OptiNiSt is composed of a web browser-based front-end and Python-based back-end. The analysis pipeline and their environments are managed by a system called SnakeMake. And the saving format is NWB, which is one of the recommended standard format for physiological data. The documentation, source code, Docker image are all open. We put a reprint paper in bioRxiv. Okay. So, any questions?
So I have some questions. So
Okay.
maybe so you will explain the OptiNiSt more detail and next time. And currently, so you have showing the bioRxiv papers. So today, so this lecture is based on these bioRxiv papers or more detail.
It's basically based on, but it's more like a hands-on tutorial. So I'm gonna talk about by running it. So
Okay,
it's not exactly the same thing, but but very similar pipeline are used.
Okay, I understand. Thank you.
Okay, and let's start that tutorial part. And I put that instruction for preparation of today's tutorial in the GitHub repository here. So if you haven't, please go to this site. And I'm not sure, but has anybody go through this and installed the Docker image of OptiNiSt yet? How many people did this beforehand? Not really.
So I have a link of the OptiNiSt tutorial page.
Thank you.
Sharing.
So please go to this site. You will see this here, and I will go to the same place. Okay. So to start, you need to have Docker desktop or the Docker engine running on your machine. So downloading and installing Docker desktop is very easy. You go to this site and download what depending on what your system is. Okay. And so after you download and install, basically, just that installation is default installation should work. But you have to be careful when you have Apple Silicon CPUs a bit. And to start, and then downloading, and then please start the Docker desktop, which is like this. So you okay, you have to engine running before downloading the image from the Docker hub. So to do this, please open a PowerShell or a terminal on your computer and execute the following command to fetch the Docker image. And here, you just run it. Because I already have downloaded it, it says it's up to date. But if you haven't, it takes a bit of time, several minutes, I guess, depending on the network condition. But yeah, please download it. And then after you download the image, if you look at the Docker desktop, you will find the image downloaded like this. Okay, and then you have to create and run the container by the following command. You just copy it and then run it. But before running it, make sure that this part, which defines the mounting directory, should be somewhere on your computer. So in my case, I created the OptiNiSt demo under my home directory. So it should be, yeah, like this. I changed this part to the home directory of OptiNiSt demo, but you can create any directory what you want. And run it, just let it run it. And then, so once you run it, you'll find, the containers appear here. And the log is shown. After log is shown like this, then please go to the local host 8000. You can use any browser, but we usually test using Google Chrome. So Google using this browser is recommended. So here, if you see this figure, this page, then it's done. You are ready to start analyzing your data. Okay, any questions about the installations or the starting the OptiNiSt?
So I'm now downloading and maybe extracting the Docker file. And yeah, so I'm doing the container making currently, but the request image platform does not match a detected host platform.
Are you working on the Apple machine?
Yes.
Yeah, that's yeah, it gives the same, right? Yeah, but I think it's okay.
It's okay.
It
That
should be
works.
okay. Yeah.
But there is nothing to, yeah, okay. So
So you look at the container, and if you have this one,
okay.
running,
I can find.
you can. So that means this it says it's running. This is just an interface to look how it, I mean, the Docker engine related stuff.
Yeah.
You can check it, or you can just check like running a container by this command, Docker ps.
Oh, okay. I'm
anyway.
going to there. So yeah, by using Chrome or going to the localhost and seem to be so OptiNiSt or images I can.
Okay. Yeah. So if you anybody having problem with starting, yeah, if you have any problem, just interrupt. I can try to solve it. But anyway, assuming that you are or you are looking at this image web page, so please, once you it's ready, you assigned see, your saving directory when you run the image, that container, sorry. In this your assigned saving directory, the input output folder should be automatically created. The OptiNiSt use this folder to exchange the input and output of the calculation through this folder. Okay, so please check whether it's created or not. If it's not created, maybe your assignment was not correct, or somewhere else where you can try to find out by searching for the input or output directory.
Sorry, so how can I checking this folder is existing? So
How can you check?
check, yes. So this is the app and studio. Yeah, so this slash app and studio data folder is existing or not. So you are saying.
Oh, this is not. You mean you changed and you don't. You have to assign what you already have.
You're saving directory. So we should change. Okay, I understand. So I didn't change. So that means that I think so we should.
Yeah. In that case, probably the Docker command gives error that you are not it cannot assign the folder.
I understand. So that means that I should making the new folders for the OptiNiSt, and so I'm working there something in its folders and the slash.
Yes.
Oh, see, Docker latest from Python is already use a container.
So in that case, please just remove this container. Like this command, docker rm OptiNiSt. Sorry, probably you need if this one.
Cannot OptiNiSt maybe just wait. I cannot remove. Huh? Why?
Did you put the if?
Okay. So maybe I can remove sender. Oh, it seems to be work well. So that means that okay, the Docker is stopped, but let's see. Wait, maybe okay. Yeah,
Okay.
be okay.
Okay, then
And I can find the input and the output folders on here.
okay. Great. Then we will go to the next step. So in the OptiNiSt, we use different tabs, 3 different tabs: workflow, visualize, and record. Workflow field creates analysis pipeline, and visualize shows the resulting plots, and record tab is for managing the pipelines. You can toggle these fields, but we start with the workflow. The workflow field, in the default, you have this rectangular thing here. This we call a node. This is a node to assign the input image. OptiNiSt supports multiple input formats such as TIFF or CSV or HDF5, which is same as NWB format, and .MATLAB format. Additionally, some microscope-specific formats are supported, like this. By clicking the plus mark here, the corresponding input node appears. I'm gonna show you. Data node, image, CSV, HD5, like this. And you can remove this by clicking on the X mark like this. And now we want to, sorry, I forgot to ask you to do one thing in the last. In addition, you have to download sample files for today's tutorial. So please go to this site and please download all the files in here in this drive. Okay, and I will go to this site. So you already, assuming you already downloaded the sample files like this, we will, sorry. So first, please click to upload TIFF file by clicking this icon. This copies the data to the input folder. And then please click the left side icon here. This is used to select the TIFF file for actual analysis, which one it should be used. So my demo folder, there is nothing in input, but I select the samples TIFF file from sample folder. Then image is uploaded, and you have this file here. And you have to select, it's already selected. And yeah, in this way, you will select what data you use for the pipeline. So after we are selecting, we want to look at the inside of the image sometimes. So please go to the visualize page click on the plus mark, and you can select the just uploaded file. Like this. This automatically introduce 1 to 10 frames in the system, and it can be seen as a movie. You can change the number of the images to look at. But if you make it too much, it will take a lot of time. So please be careful. And yeah, let's see. You can see a movie like this. Okay. And to create the workflow, we for the first test, I will create a SUT2P pipeline. So to create the pipeline, you have to connect different nodes. Each individual node corresponds to one particular process. And you have to connect the connectors. Connectors are these colored small rectangles, like this. This is how we create a pipeline. There is chat. Okay. So yeah, please go to the node algorithm SUT2P and make this pipeline like this. This means the first assign the input image and format input file for SUT2P format, and then do the motion correction and extract the cell from the fluorescence. The color of connectors indicates the format of input and output. As you see, like for example, image data should be frames by Y and X pixels. Fluorescence or spiking activity should cells by frames. So the connector the connectors cannot be connected if the colors is different. This ensures the format of the input and output to be the same between the connected nodes. The exception is black connector. In this particular black one can be connected with any other color. Okay. So for example, I can connect this and this, but cannot this and this. You cannot do this. Okay. And you can create in such a way the R pipeline. But another convenient way is to import the other one's workflow. In the sample data, this one, workflow 1 YAML file can be used to import the pipeline. Actually, this is the same one as I created just before. But in this case, the image is vacant. This workflow contains the information, only the information about the structure of the pipeline and the corresponding parameters. So you need to assign the input file you already uploaded the file to the input directory. So you just select the target file, and then you can ready to start running this pipeline. Okay. Okay, let's start running this. Just click to run it. You can name any name as like, so I will put this to be done. Then I start running. Once you start running, you will see this ID as assigned, and the name I just created was shown here. And this ID, same ID was created in the output directory here, 7AEE, 7AEE. This is the output file, all the output file for this particular pipeline. And if you like to stop this, you just click this cancel button, and then you can cancel it. Okay, the first step was already done. If the process was completed, the check mark is shown. And if this has an error, it shows the exclamation mark is shown. Okay, I think we're almost done. Oh, aborted.
So in my case, this is finished and seem to be work well.
Okay. Yeah, sometimes like this, it looks like weird, but anyway, when you each individual node has param button. This clicking on this parameter button shows the parameter, and you can change the parameter. Okay, for example, I cannot change it. But you, for example, you may change the parameter, and in the run all, you will run all the processes. But if you have already run and completed part of the pipeline, you can use run button instead. This run button do not skip the already processed part. So it's earlier, it finishes earlier than before. And then just do the one that the change was happened. So in that way, you can manage spend do not spend time for the wow, I could do this but I'm not sure what happening. Yeah, in this way, you can create the pipeline. And another thing, another part is a record. So this is the record of the just finished workflow. Let's see. So this part is a timestamp of the start and end of the process. And this is a unique ID I'm talked about in the shown in the left upside of the workflow field. And the name is the user-defined name. And this icon represents the reproducing the pipeline on the workflow. So you can reproduce the listed the work each individual workflow by just clicking by this clicking on this icon. And the three download files are corresponds to the workflow is the description of pipeline, which is same as the one we uploaded on the workflow page to create easily the workflow pipeline. And SnakeMake file is a list of execution for HPC use. This is used when you want to run the pipeline in the high performance computer clusters. And almost similar to the content is similar to this workflow, but it actually assigns the name of the data and also the order and so on. And the NWB is the contains analysis results as a NWP format. Okay. So any questions?
So I have finished the pipeline and I can find the switch speed load results. And I just checking there. So yeah, the region of interest is successfully estimated. Unfortunately, なんかその、なんかフロレッセンス tab is existing. And so this is some kind of time series of the horizontal is the time and the vertical is some kind of a number of activity, but there's nothing data on free. So
Thing is shown.
yeah, so nothing is showing on this fluorescence tab in the output of the switch to be ROI's results. I don't know why. So yeah, there's a cell ROIs existing, seem to be working well in the some different colors and the region of interest in many ROIs and the all ROIs and the non-cell ROI and cell ROI is detected, but the fluorescence activity is
activity is not shown.
Shown seem to be, yeah.
Okay. I have to. So let's go to the here. So you go to the visualize part and then select the item post brief image in here and select ROI here, cell ROI here. So you have this image, right?
Oh, I understand. Oh, yeah, seem to be, yeah, I can find.
Okay, and then please click the on the right side any or downside of the plus mark and show this second panel and select fluorescence.
Yes.
And then select 0, which corresponds to this panel. So
Yeah.
by doing this, this links, this fluorescence is linked to this first position image. So by this, you should be able to show by clicking on this cell position, you will see this kind of fluorescence time course, right?
Clicking. The clicking and clicking, so increasing the time series.
Yeah,
Now,
you can toggle the visibility by clicking on
here.
the line also.
Okay, I understand. So I completely so find the results of fluorescence.
Okay, and on the here, if you look at the select this 0 panel or the 1 panel, you can toggle it and you can change the left side bar. I mean these are corresponding to this corresponding panel, which is bluish highlighted. And you can change the appearance of the plot by changing these parameters. For example, vertical offset will change the offset of this fluorescence, or you can change the frames or the second the metrics of the x-axis, and so on. And also you can save the figure by selecting and clicking on the camera mark on the panel. Okay. So I can do this like this, ref image, celluloid, and fluorescence. And you will be able to look at this. It looks not very nice, but this one might be nicer. Okay. And you can select PNG. I will select yes. And in this you will be able to see the plot. Sorry, see the plot was the image was created and downloaded to your download folder. Okay. Yeah, this is I went through the one of the workflow, but I have different workflows prepared. I briefly explain what it is. The second workflow is the event-triggered averaging. And this workflow 2, create the event-triggered averaging from the HDF5, which is maybe a WB file that you already created by OptiNiSt. And the behavior data, which is CSV file, is a list of time course of the triggers. In this case, which I prepared the mouse data, 2-photon data. So you while the animal is listening to the auditory system stimuli, the column one of the this CSV file is like this, and this first column is assigning the timing of this auditory stimulus presentation as 1 among 0. And this is triggered, this 1, 0 to 1 is a trigger time. And then you can, this ETA detect the this CSV files 1 to trigger, and then some to average each individual cells fluorescence. Okay, so that, the result is like this. You will see the triggered averaging. Okay. And
Go back to the previous slide. So yeah, I cannot do this. So go back to the how to read the file. So
okay, and how to read the file. That you mean that this next one?
so I find this.
Yeah, you upload the file, and you it's a bit difficult. You have to upload the file. I prepared this one, NWB file, and you have to open it. And in this case, this file is nested. So you have to assign the correct one, which is a Kaiman, sorry, this one, fluorescence data, which is the 3,000 by 50, 3,000 frames by 50 neurons data, fluorescence data. And this is the CSV file, behavioral CSV file. So run this ETA.
Okay.
This is what you have to do.
Thanks.
Okay, the third example is the multiple analysis. In addition to event-triggered averaging, principal component analysis, or the correlation between individual pairwise correlations between neurofluorescence data. And this is for showing the cell position image from the HDF5. So these the OptiNiSt can control such bifurcations also. So you can create or compare different analysis result simultaneous by creating one pipeline within one pipeline. The result might be looks like this. And also yet another example is a comparison of different cell extraction method. OptiNiSt has implemented the Kaiman, CNMF, and LCCD fast cell detection algorithm, and also the SUT2P ROI detection, which we did in the first workflow. You can compare the result within this one workflow. Yeah, Also, the result might be like this, but
So, there is some question from the 他のさんで、なんか日本語なんですけど、いかにデータの信頼性を高めるためのプロシージャル的ワークフロー構造っていうそのクエスチョンなんですけど、ちょっと僕意味がわかんないんで、他のさんなんか、
話して チャット、いかにデータ間での信頼性を高めるためのプロシージャルというか、う
例えば、
ーん、
例えば素人質問なんですけど、データをいかに早く、コストを早く、民間のソフトで抜くっていうのがあるんですけど、例えば3D ソフトをいかにアーキテクチャで早く、その画像を早く作り上げるっていう、そのプラグインソフトがあるんですけど、そういう感じのものではないのですか？例えば画像と動画とかを、いかに組み合わせて、よりクオリティの高い、そのデータにしていくっていう段階を含む、そういう感じのものではないってこと
うん、
なんです。
違います。う
あ、
ん、
違いますか？あ、すい
はい。
ません。すいません。
多分、この最初のところで、なんとなく雰囲気的にはお話ししたつもりになっていた、そうですね、まあ、いろんなメソッ
大丈夫です。すい
ドが、
ません。大丈夫です。
いいですか？そうですね、プラットフォームが違うので、それを統合したい的な意図で作られていて、早くっていう信頼性を高める。うん、そうですね。うん。ちょっと私がちゃんとそのご質問の意味を分かっているかどうか不安ですが、中身的な問題というよりかは、なんていうのかな、いろいろ統合できるなんかなんていうんでしょうかね、フレームワークっていうんですか、というような意図です。はい。はい。大体説明は終わっているので、日本語になってしまった。日本語でも英語でも、ご質問があればよろしくお願いします。画面の共有停止しちゃった。えーで、so we are proactive in collecting user feedback and improving this framework. So please let me know whenever you have bugs or the additional function that you may want to use in this framework. That would very helpful for our development of the next additional functions.
Yeah, but anyway, so I can do your the OptiNiSt analysis now. Yeah, it seems a great.
Okay,
Yeah,
great.
okay, yeah, I can do it.
You, and yeah, basically, our OIST team, led by Kenji Doya, and the Araya team is especially for the area people, engineers worked very hard for creating this system by the support of AMID. Okay,
That's all?
that's all. Thank
Okay,
you.
thank you very much. But anyway, so this tutorial will be uploaded to the YouTube and all the person. If there's something problem, so please tell me. And yeah, today is this is the end of the presentation. Is any question and comment in more general thing is okay, and Japanese is also okay.
You also, we can use the Slack of the digital brain. Just ask me directly or yeah. that also welcome.
Okay, thank you very much. And so next data brain seminar will be held in the, I forgot the details. So maybe November 12, Okay, so thank you very much for the coming and yes. So let's see you do the next timing. See you. Thank you very much.